In this video, I want to do an example with an inscribed rectangle inside a function. So you'll see a rectangle is formed with the vertices on x-axis, y-axis, the origin, and the function 9 minus x squared. What value of x would maximize the area of the rectangle? So what we're saying here is that we're going to put a point on each axis and on the origin and on the function, and out of this we're going to make a rectangle. Okay, so we want to find what x should be, where should we put x to give us the largest possible rectangle. I should just mention here that there was nothing about this saying it had to be in the first quadrant. It certainly could have been over here. We could have drawn the rectangle over in this area. It wouldn't, because I want to inscribe this, it wouldn't have worked to put it down here because it wouldn't have then touched the function to have a point there. So it's going to be limited here to this kind of picture. I guess with any problem like this, I always begin by just drawing my picture so I know what it looks like and then saying, all right, it touches the function at the point x, y. So area is what we're trying to maximize here, right? So we're going to maximize the area. Area in our case is equal to the length of the bottom, which is x, and the height, which is y. And while these problems always seem tricky, they actually maybe have the easiest kind of substitution or constraint because we know what y is equal to. I'm going to put this over here. We know that y is equal to 9 minus x squared. So we can just substitute that in right away, that the area is equal to x multiplied by 9 minus x squared. So that's 9x minus x cubed. So the derivative, dA dx, is 9 minus 3x squared. Of course, we're setting that equal to 0. So 9 equals 3x squared. So 3 equals x squared. So x is the square root of 3. If I put this, on a number line, oops. You pick a number, remember we're going back to the derivative, pick a number less, like 1. 9 minus 3 times 1 squared, this is positive. Pick a number bigger than square root of 3, like 3. 9 minus 3 times 3 squared is negative. It is a maximum. Now, the one thing I want to mention, when we solve with the square root, remember we could have done plus or minus, and most of the time we say, well, the domain here is such that the negative is not going to work, so we aren't going to worry about it. But actually, the negative could work here. Because remember, we said there was nothing saying it couldn't have been this rectangle. So, this x, this is the square root of 3. This would be the negative square root of 3. So you really could pick either one and you would get the same size rectangle.